Hi students, in today's session I am going to explain two important topics. One is functional isomerism questions and tautomerism. In previous video I had explained functional isomerism, which and all functional groups exhibit functional isomerism. Detailed explanation I had given. So now in this video I am giving one question which is repeatedly asking question in JEE and NEET examination. C4H10O, H10O, how many alcohols possible? How many ethers possible? Afterwards, how many primary alcohols, how many secondary, how many tertiary, different ways they are framing questions. For all these questions, first let me start explanation. Afterwards, we'll discuss the question. C4H10O, here we are writing 4 alcohols, 3 ethers. 4 alcohols, 3 ethers possible. Totally 7. But in this 4 alcohols, 2 are primary alcohols, 1 secondary, 1 tertiary alcohol. 2 primary alcohols and one secondary alcohol, 1 tertiary. So finally I am writing 2 primary, 1 secondary, 1 tertiary. Okay. Based on questions I am giving concept here. Alert. Ethers. How many ethers possible? 3 ethers. These 3 ethers we call it as metamers also. Recent NEET examination they asked this question. C4H10O molecular formula. With this, how many metamers possible? 3 metamers. The 3 ethers we call it as metamers. Metamers is nothing but compounds are having same molecular formula, but arrangement of alkyl groups on either side of the functional group is changing. So I'll show after explanation the concept. See, first we'll write the alcohols. Alcohols, what is the functional group? OH, right? CH3, CH2, 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 OH. This is what we call it as primary alcohol. This is actual name 1-butanol. How to give the naming and all previous videos I had explained. Please go through that. So 1-butanol, this is what? Primary alcohol. How can you say it is primary alcohol? OH group attached to primary carbon. How can you say it is primary carbon? It is attached to only one carbon. Hope clear. Now explanation, introduction part I had explained. Please go through that. Primary, secondary, tertiary, CH2, CH3. What is this? We call it as students. This is 2-butanol. What is this? 2-butanol. Is it primary alcohol or secondary alcohol? Definitely it is secondary alcohol. How can you see? This OH group attached to secondary carbon. Secondary carbon means it attached to 2 carbons, right? So okay, now next one. Third one. What is the third one? Look into this. CH3, just you write chain. Isopropyl. We have taken iso is nothing but exactly L shape. Second carbon it will go L shape, inverted L like. So what is this? CH2OH, right? Okay, this is one alcohol. What is this name? 1, 2, 3. Because least priority, this is the functional group, no, least number we have to give that particular functional group having carbon, right? So what is this name? 2-methyl 1-propanol. IUPAC name, right? Now is it secondary or primary or tertiary? This is primary. Because why? It is attached to only one carbon. This is primary alcohol. Clear? Now next one. With this one more alcohol I am writing. What is that? CH3, CH3, CH3. This is OH. That's all. C4H10O. All. You can check it everywhere. So same molecular formula. This is what we call it as naming 1, 2, 3. 2-methyl. Yes, tell me. 2-propanol. That is 1-propanol, this is 2-propanol. Is it primary or secondary or tertiary? Tertiary alcohol. Clear? So I said first, how many primary alcohols? 2. How many secondary? 1. How many tertiary? Clear? Totally 4 alcohols. Now here they'll ask questions. Look into this. Structure 1, structure 2. Structure 1. Take it as structure 1 this is. And this is structure 2. This is structure 3. And down one structure 4. Structure 1 and 2. 1-butanol, 2-butanol. Was structure 1 and 2. Positional isomers. Positional isomers. Right? Positional isomers. How can you say within second? But, root word is not changing. Chain is not changing. 1, 2. Position of OH group is changing. That's all. Next one. Structure 1 and 3. Structure 1 and 3. Can you guess what is this? Structure 1 and 3. 1 and 3 within 1 second. Here prop, here but. Chain changes. That's it. Chain isomers. Clear? Now, next one. Structure 2 and 3. 2 and 3. Again same story. 2 and 3 also chain isomers. Why? Because chain changes. Right? Now, structure 3-4. Another combination. Structure 3-4. Can you guess what is this answer? Structure 3 and 4. See, within 1 minute you have to give answer. 2-methyl, 2-methyl. 1-propanol, 2-propanol. 1-propanol, 2-propanol. That's it. Positional isomers. Root word no change. See students, from single concept how many questions chances are there. Please go through this topic. Everybody prepare well. This is one of the most important concept in functional isomerism. Okay, now ethers. 4 alcohols completed. Now I am writing fifth structure is ether. Ether CH3, CH2, O, CH2, CH3. See, with this molecular formula C4H10O, how many? Totally 4 carbons. See, 10 hydrogens, 1 oxygen. This is what we call it as diethyl ether. It's a common name. What about IUPAC name? IUPAC name is ethoxyethane. Ethoxyethane. Right? Now, next. 6th one. CH3 alkyl groups, just arrangement you can change it. Here 3 you can write, here 1 you can write. That's it. Then what we call it as methyl propyl ether. What is the IUPAC name? IUPAC name is, see, methoxy. This is a side chain, this is root word because the longest chain, no? So what is this? Methoxy propane. Alkoxy alkane, this is methoxy propane. Clear? Now one more is there. 3 ethers I said to you, right? Now one more you can write. CH3 isopropyl. That's all. See, 4 carbons, 6, 7, 10 hydrogens, totally 1 oxygen, right? This is what we call it as isopropyl methyl ether. But what about the IUPAC name? Yes, this is methoxypropane. This is 1 methoxypropane. Now here, what is the IUPAC name? IUPAC name 1, 2, 3. This is 2 methoxypropane. Okay. Hope everybody clear this topic. This is 1 methoxy. 1, 2, 3. 1 methoxypropane. 1 methoxypropane, 2 methoxypropane are structure 6 and 7. 6 and 7. So what is this? Positional isomers. Positional isomers. Next. Metamers. What is metamers? 5th one, 6th one, 7th one. 5, 6, 7 are metamers. Metamers, right? So compounds are having same molecular formula but differ in their, tell me, arrangement of alkyl groups on either side of the functional group. That's it. That's it, students. So hope everybody clear this topic. Totally 4 alcohols, 3 ethers. In that metamers they are asking, positional isomers they are asking, and next one functional isomers they are asking. Suppose structure 1 and 2, 1 and 6, or else 1 and 5, 1 and 5 functional isomers. Functional isomers, and 1 and 6 functional isomers, 1 and 7 functional isomers. Like that they are framing the questions. Okay, students. Now next, I am giving one question. Everybody must try this one. Primary, secondary, tertiary amines I am giving. So this is also one of the repeatedly asking question. So C4H11, C4H11N. So this is how many primary amines, how many secondary amines, how many tertiary amines possible they are asking. So please note it. C4H11N. Second question. Second question. Write possible number of isomers with C4H11N. I have given no starting 4 alcohols, 3 ethers, in that again different types. Here also everybody write it. I am giving hint also. So this is amines. We have primary amines. We have primary amines and secondary amines. Secondary amines are amines, if you wish. And next one, tertiary amines. How many primary possible? How many secondary possible? How many tertiary? Total number of isomers. Everybody comment me answer. Everybody comment me answer. Okay, everybody try to do this. Now, C3H6Cl2. C3H6Cl2. Possible isomers. Possible isomers. They are asking question. Now look into this. Carbon, carbon, carbon. How many chlorines? 2. First position only you can write. That's it. Remaining filled with hydrogen, 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 or else you can write CH2, CH3 also, your wish. Is it satisfied or not? How many carbons? 3. How many hydrogens? 1, 2, 3, 4, 5, 6, 2 chlorine. That's it. This is what we call it as 1,1-dichloropropane. Right? Okay. Next possibility. Can you write with 2, 2, 2, 2? Easy way. See, this is hydrogen. Okay, carbon, carbon, carbon. Okay, first you can write this is methyl group only. This is also you can write methyl group only. 6 hydrogens, 1, remaining 2 chlorines here. That's it. Right? What is this guy name? 2,2-dichloropropane. This is next isomer. Right? Now, another possibility. I think you got my answer. 1, 2. You can write 1, 2. 1, 2 possible, no? 1, 2, 3. Here chlorine you can write, here chlorine you can write. That's it. This is CH3 group, here hydrogen. 1, 2, 3, 4. 1, 2, 3, 4. 3, 2, 5, 6. That's it. This is what we call it as 1, 2. Dichloro, 1, 2 dichloropropane. Now next one. 1, 3. You can check it. Yes, this is the last possibility. 1, 3 dichloropropane. So totally how many possible students? Answer is 4. Right? That's it. Answer is 4. See first question, what is my question? How many alcohol with C4H10 move? C4H10 move, how many possible isomers I said? Totally 7. We will write answer here. C4H10 move, totally 7 isomers possible. In that 4 alcohols, 3 ethers. Out of 4 alcohols, 2 primary, 1 secondary, 1 tertiary. Out of 3 ethers, 3 are metamers only. I have written down structures also. Now next one. With this 3 questions I had completed, students. Next one, monochlorination they are asking. Monochlorination. Next question. Question number 4. Propane on monochlorination. Propane on monochlorination. How many products possible? How many products possible? That's it. Propane. CH3, CH2, CH3. Monochlorination. That means only one chlorine replacement. Here primary, this is secondary, this is primary. This primary is same. This primary is same. If you replace here hydrogen, name is same. CH3, CH2, CH2, Cl. What is this? We call it as 1-chloropropane. 1-chloropropane. Okay, next one, second one. See students, just now I said one point. If you replace here also, that is we call it as 1-chloropropane only. If you write IUPAC name, you will come to know. Next, secondary one. CH3, right? CHCl, CH3. This is what we call it as 2-chloropropane. Okay, sometimes they don't give answers. Here question A, question B. This is answer A, this is answer B. A and B are chain isomers, are positional isomers, are functional isomers. They can frame questions like this. Finally, structure A and B are, what is this? 1-chloro, 2-chloro, pro. Root word no change. Then it is A and B are positional isomers. Positional isomers. Next question. Butane on monochlorination. How many products possible? After optical isomerism completed, I will introduce the term chiral carbon also. Later I will do. Fifth question. What is this fifth question? CH3, CH2, CH2, CH3. This is what we call it as butane. Right? Above one propane, down one butane. Long chain means N-butane also they will call, both are same. On monochlorination. This is primary, secondary, right? CH3, CH2, either this side or this side you can replace, finally name should be same. This is what we call it as chlorobutane. Okay. Now here either this carbon, and any one secondary carbon you can replace. CH3, CH, Cl, CH2, CH3. Then what we call it as 2-chloro-butane. 2-chloro-butane. These two again positional isomers. Okay, like that you will get question. Now next question. One of the important question. Cyclohexane. Cyclohexane. What is cyclohexane structure? Like this. If you have written alternate to double bonds, then that is benzene. Only like this. This is molecular formula C6H12. Okay. Now on monochlorination. Cyclohexane on monochlorination. How many products? One product. One product. Because this is secondary, all are same type. All are same type. That's why the product is same. Only one single product you will get. I am writing answer here. Look into this. Any hydrogen. Any hydrogen if you replace, finally answer is this one. Monochlorination, one product. Because all are secondary. Now next one. Neopentane. Neopentane. Seventh question. Neopentane on monochlorination, how many products possible? Neopentane on monochlorination, how many products possible? How many products possible? Check it. CH3, 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 all are CH3 groups, right? This is neopentane. Neopentane. Neopentane on monochlorination. How many products? This is primary, this is primary, this is primary, this is primary. On monochlorination, you will get only one product. That is 1-chloro. Name you can give 1, 2, 3. Right? What is this? 2,2 dimethyl 1-chloro 1-chloro 1, 2, 3. 2,2 dimethyl 1-chloropropane. Right? That's it. You can replace here. Name is same. If you replace here, name is same. Replace here, name is same. All same. So hope everybody clear this topic also. Now once optical isomerism completed in our videos, then I will give more questions. Chiral carbon also I will introduce. Okay. Now here tautomerism. In this video, last topic is tautomerism. Tautomerism is dynamic keto form to some organic compounds more stable in enol form. Some organic compounds more stable in keto form. Enol form to keto form conversion we call it as tautomerism. Enol means here we have double bond and OH group. Double bond means what we call it as ene. OH group is nothing but what we call it as ol. Keto. Keto means C double bond. Most of the organic compounds are stable in keto form only. Not all. So which is stable form it can convert. Okay. Now I'll give you one question. You can understand more better. So propanone. Propanone is keto form. Right? It's enol form. they'll ask, or else they will give enol form, they will ask you to write keto form. Okay, so see students, I am writing. First I am taking enol form, enol CH3 See, look into this. This is enol form. Enol form. These two are dynamic equilibrium. Dynamic equilibrium, keto form and enol form. Dynamic equilibrium, interconvertible. See, double bond is there. En. OH group is there. Old. Enol form. This is not stable. This is not stable. Its stable form is ketone. How it will convert? See, look into this. Here, to understand more better, I am writing expanded form of this one. The same structure I am writing in little different. What is this? OH, right? Here CH2. What is this? CH2. That's it. Now, what happened? This hydrogen shifts here. This double bond shifts here. That's it. Now you will write CH3, don't disturb, as it is you can write. This is C. See, double bond shifted here, no? See, one bond shifted here, no? Already one bond is there that you have written. And this bond shifted here, double bond go. Now oxygen. This hydrogen gone here. That's it. This is keto form. So finally, propanone keto form, write enol form. Enol form to keto form. They'll ask you keto form, or else they will ask you enol form, anything. No problem. Okay. Now next, one more question I am giving. Everyone try this one. Already I have given one question. What is that? C4H11. Along with that, another question, tautomerism. Tautomerism exhibit CH3 C double bond O CH2 CH3. This is previous year question collected. So write this one. What is this? This is keto form, right? What is the enol form? Can you write enol form? Shifts here only. Where active site oxygen? No? This hydrogen shifts here. This bond comes here. CH3 C H double bond. Yes, tell me CH3, right? That's all. That's all. This is enol form. This is enol form. That is ketone form. Actually, some of the students, they are writing here also this methyl group they are using, that is not stable. This is more stable. This is more stable because more acidic hydrogen. This is more acidic hydrogen. Active methylene group. Active methylene group. Active methylene group is more acidic. That's why here shifting is the more stable product. Okay. This is tautomerism, students. Tautomerism I had completed. And another points I am writing under tautomerism. It is one type of functional isomerism. 1,3 shift isomerism. This is also called as keto enol form. So dynamic equilibrium, different ways they are asking theory questions. This is one type of functional isomerism only. Okay. Now I am writing those points also here. It is one type of functional isomerism. Because here propanone is nothing but keto form. This is enol form, no? That's why functional enol to keto. Next one, 1,3 shift isomerism you can write. 1,3 shift. Here this is 1. Imagine this is 1, this is 2, this is 3. 1, 2, 3. So that's why 1,3 shift isomerism also they will call. 1,3 shift isomerism. Even above example also you can take it. And this is a dynamic equilibrium. Keto enol form isomerism, dynamic equilibrium, different names they are asking questions. Okay students, with this structural isomerism completed, chain isomerism, positional isomerism, metamerism, functional isomerism, and next tautomerism I have completed. Ring chain isomerism also there. Ring chain isomerism also, just brief explanation I will give you. Ring chain isomerism. So here generally cycloalkanes. We are taking here cycloalkanes, alkenes and cycloalkanes. Not only this one. It will go alkynes and cycloalkenes. So many aldehydes and cyclic alcohols like that. But one example I am giving, ring chain isomerism. Ring chain isomerism exhibited by alkenes and cycloalkanes. Alkenes and cycloalkanes. And alkynes. Only few combinations I am writing. Alkynes and cycloalkenes. Next, alkadine, cycloalkene, aldehydes. This is one of the important one. Aldehydes and cyclic alcohols. Next one, ketones and cyclic alcohols, and ketones and cyclic ethers. Different combinations are there students. Ketones and cyclic alcohols and ketones and cyclic ethers. Ketones and cyclic ethers. Now, first one I am giving alkenes and cycloalkenes. One alkene you can tell. What is this alkene? Any alkene. CnH2n. First one. Alkenes and cycloalkenes. CnH2n, where n equal to 4 you can take it. Then what you will get? C4H8. With C4H8, what is this alkene? Can you write what is the alkene C4H8? Butene. Butadiene or butene? Check it. 1, 2, 3, 4. Right? Now, CH3, 6, double bond, 7, 8. This is what we call it as 2-butane. With this you can write cycloalkanes. That's all. What is this? CH2, 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 like this. This is cyclobutane. That's it. Can you write one more, students? What is this? Cyclic ketones and cyclic alcohols. Or else you will take propene. With the cyclopropane. Like this. See, what is the molecular formula? C3, 1, 2, 3, C3. How many hydrogens? 5 to 7. 3, 4, 6. 3, 4, 5, 6. Okay, here also CH2, CH2, CH2. That's it. You can write pentene, cyclopentane, hexene, cyclohexene. Like this we'll write. Okay. So with this ring chain isomerism also completed. Remaining you can try it. If you have any queries also comment me. In upcoming videos definitely I'll give you answers. Okay. Now next one. Last one. Cyclohexane or else hexene. What is hexene? CH3, CH2, CH2, C1, 2, 3, 4, 5, 6. 1 hexene. 1 hexene, right? What is the molecular formula? C6, 3, 5, 7, 9, 10, 12. Cyclohexane. That's it. This is cyclohexane. With this ring chain isomerism also completed. So structural isomerism successfully completed all the parts. Next video I am going to do geometrical isomerism, cis, trans, EZ, and next one syn addition, anti-addition, and different questions are there. Geometrical isomerism, all the questions I am going to discuss. Afterwards, optical isomerism. Okay students, thank you. Thanks for watching.